Here's an introductory problem on association and correlation between two quantitative variables. It's problem 17 from chapter 7 of Bach, Feldman, and DeBow. And they've got a data table here of various types of vehicles, vehicle models from 2001. And they measured they didn't measure, but they took the advertised horsepower, so we're trusting the manufacturer to be correct about that, and the expected gas mileage. This is in horsepower, which is a rather antiquated measure, but it's how you measure cars in the United States. And gas mileage, miles per gallon, and I'll make a comment about the choice there. That's also somewhat specific, very specific to the United States. And we're looking for a possible association between power and economy. If you have a more powerful car, is it going to get better or worse gas mileage? And is there a simple is there association of any kind, and is there a simple linear correlation? And we'll think about that. So what they ask specifically is the first thing you should do always make a scatter plot. Whenever you're looking at two quantitative variables, we want to make a scatter plot. So I did set that up on the calculator already here. What I did is stat edit. I went over from L1 and all that stuff. I went over far enough to get to blank things on the top, and I've got power for the horsepower and the econ for the miles per gallon, the fuel economy. And I've put in the data, 14 pieces of data for each. Okay, and then so we can go to stat plot. This is you could do this by hand. It wouldn't be ridiculous to do 14 points by hand, but it's getting to where we probably want to use the calculator. And making a scatter plot by hand is not like, I don't think I need to tell you how to do that. It's not so hard. So I turn plot 1 on. Okay, now I've got the scatter plot type, so that's set. Now to get that name, I go to second list names, and we see. Now let's go ahead and use power as the x variable. And again, second list names, and then okay, there's econ as the y variable. Now we don't really have to do that. We could say here we're thinking of power as our explanatory variable and econ as the response variable. So we're sort of saying if someone gives us the horsepower, what would we predict roughly about the mileage? We could do it the other way. It's just right here. It's just it's kind of a neutral choice. Okay, now we don't know what kind of thing. Okay, I did zoom 9 and here's the scatter plot. Now, whenever you do zoom and you let it take control, you should always go to the window and see what's it doing here. Okay, so the values are between 95.5 and 329.5 for the horsepower. Makes sense. Okay, that's pretty good scattering for these values. These values actually go between about 125 and 3 something. Okay, 310 maybe. And then here's the values for the y between about 6 and 35. Okay, so it gives plenty of room for the graph. Okay, so describe the direction, form, and strength of the plot. That's the next thing. Okay. Well, it's definitely a negative association, as we would pretty much expect. A more powerful engine is going to be less efficient, probably. Negative association here, and it looks roughly linear. Okay, it looks somewhat straight line. There's definitely some scatter here, but there's this. It's not ridiculous to say it's roughly linear, and it's I guess I'd say it's fairly strong visual association. Okay, so a strong negative linear association. One thing is that these two out here, if you take these two guys out, this wouldn't be nearly as convincing to be a strong linear association. So it really depends on what we think about these two guys. They're not outliers. They don't buck the linear trend that seems to be shown, but they reinforce it very strongly. And it depends on if we really think these are data points that we care about a lot. We might think, well, actually, maybe these are kind of special and we want to segregate them off on something else. Okay, but certainly with them in there, it looks like a pretty strong association. Okay, and then part C, they say find the correlation. Okay, so I've gone ahead and set up the calculator as they suggest in the book to do the diagnostic on command just once. You'd only have to do that once. And now I go to stat calc. There's two versions of linreg, and what we want is linreg number 8. And then I'm going to do again list. I'm going to go down to power, and then comma, and then second list, and then econ, and enter. So this gives me a suggested straight line fit of 38 minus 0.09x, and we'll deal with that later in terms of getting more information out of the idea of a linear regression. But the main thing we're trying to get here is the R value. It's negative, and it's pretty close to 1. And that's a good thing, because we're predicting it's going to have a strong negative linear correlation. And that's what we expect. So what we're getting is R equals minus 0.8. Let's say 8. Probably more than 2 digits are really significant here. Okay. And then D, let's just summarize. What does the plot say about fuel economy? Okay, so the plot and the R value say that there appears to be a fairly strong, well, we can say strong, the minus 0.8 is pretty strong, a strong negative linear correlation between power and fuel economy. The bigger the engine, the less fuel economy it's going to get. Now, I have to say one thing, though, here. The United States, we tend to measure fuel economy in terms of miles per gallon. And the number's good when it's high. Almost everybody else in the world measures in a different way. We could measure gallons per mile, or usually it'd be like liters per 100 kilometers is a standard measure in most parts of the world. Okay, that's something. This is good when it is low, because that's the actual usage per mile. And one thing that's interesting is that that's actually we'd actually be more likely to find a linear association between that and horsepower than there is with the gas mileage. Because if you double the size of the engine, it's certainly not going to automatically double the amount of liters per used per 100 kilometers, but it's more plausible than a linear association with gas mileage, which is 1 over this number. Okay, the two measures are reciprocals of each other. So I find it interesting that they're using the gas mileage here. That makes sense for a book for people in the United States. But we might actually find a better association, or a more meaningful association, if we actually took the reciprocal of these numbers. But this problem is probably not the place to go into that right now. We'll talk about re-expressing data, which that really falls under in a later video.